Hello students, in this video we are going to see about transportation problems. Before that, kindly subscribe my channel and press the bell button. Then only you can get a notification whenever I upload the videos. Okay, come to today's video. We are going to see the optimal solution using Modi method. In my previous video, I have done a problem using Modi method. This is also same method, but here in that we got the Dij value as greater than 0. But in this problem, we are going to get Dij value less than 0. That is, we are going to do a problem with loops. Okay, so we can call Modi method as UV method also. So in this problem also we are going to see the optimal solution, but here we are going to get Dij value as negative. If it is negative means we have to form a loop, and from that we have to go for the better optimal solution. This is the problem given. We are going to find the optimal transportation cost of the given TP using least cost method. Usually, if they are not asking you to use a particular method for finding the initial basic feasible solution, means we have to use only VAM. Okay, so just they are asking you to find the optimal solution or solve the given TP. Solve the TP means first we have to use VAM, then Modi method has to be applied. Okay, that only we did in the previous first problem. Okay, in the previous video we used VAM, then we used Modi method. But here particularly they are asking you to use the least cost method for the critical solution. What do you mean by a critical solution? It is the initial basic feasible solution or starting solution. So it has a different name, critical solution. So for finding the critical solution, we have to use least cost method. From there, we have to proceed Modi method. So first least cost method, then Modi method. Is it clear? I repeat, if simply they are asking you to find the optimal solution or solve the given TP means first we have to apply VAM, then Modi method. But we have totally three methods, no? Northwest corner rule, least cost method and VAM. Particularly if they are asking you to use a method for finding the IBFS means you have to use that concerned method. If not, go with VAM. Okay, here they are asking you to find least cost method. In detail, I am not going to use this least cost method. In my previous video in TP for finding the initial basic feasible solution, I have explained how to use the least cost method. Kindly go through that, and before seeing this video, go through that video, then come and watch this video. And again I repeat, please kindly subscribe my channel, then only you can get regular notifications. As usual, before going into the solution, first we have to check whether the given TP is balanced or not. How to find a balanced TP? Summation AI equal to summation Bj. Summation AI means row total, summation Bj means column total. See the row values, sum and tell me this is A1, this is A2 and A3. When you sum, you are getting 340. So AI summation is 340. And when we sum this column total, 40 plus 50, 90, 90 plus 70, 160, this is 250, 340. So this is also 340. So summation Bj is also 340. Both are equal. Therefore, the given TP is a balanced one. So this is also a balanced TP. From the balanced TP only we are starting the solution, and I have written the answer when we use the initial basic feasible solution. I am not going to do it in detail. After using least cost, I am getting these allocations. Allocations we have to mark in the left side. So whatever we are allotting, we have to mark in the left side, because the next we are going to calculate Dij values, that we have to write in the right side corner. Okay, so left side corner you have to write the allocations within boxes. Right side corner we are going to write the Dij values within brackets. After that, we have to find the initial basic feasible solution. Here they are using the term critical solution. Therefore, the critical solution, critical solution is equal to what? How to write the critical solution? Cast into allegation. 1 into 50 plus 2 into 50 plus 6 into 10 plus 3 into 20 plus 7 into 90 plus 5 into 30 plus 4 into 90. You have to multiply everything, then we have to add and write the critical solution below this table. Then we are moving into the optimal solution. This is the starting of the optimal solution. We are going to start the optimal solution. Before that, we have to check the condition. If the number of allegations is equal to m plus n minus 1, we can go. This kind of solution is called non-degenerate solution. So first we have to check how many allegations are here and what is the row total, what is the row number, what is the column number. So m denotes the row number, n denotes the column number, minus 1. Count the number of allegations: 1, 2, 3, 4, 5, 6, 7. So the number of allegations are 7. Row number is 3, column number are 5. Am I right? So number of allegations are 7, row is 3, column is 5. So 3 plus 5 minus 1, which is equal to 8 minus 1, 7. Therefore, number of allegations, what we got, no allegations, is equal to m plus n minus 1. Therefore, the solution is non-degenerate. If it is generate means the procedure vary, but here we are dealing with only non-degenerate solutions. That is, the number of allegations is equal to m plus n minus 1. What we have to do next? Next we have to find the Dij values. Dij values are calculated only for the unoccupied cells. How many unoccupied cells are there? 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 Dij values we are going to calculate, isn't it? What is the formula for Dij? Dij is equal to Cij minus of Ui plus Vj. This only we are going to calculate. For that we are in need of Ui plus Vj values. So come to the calculation of Ui Vj values. For all, we are going to write the equation Ui plus Vj equal to Cij. For which cells we have to calculate this equation? For all occupied cells. How many occupied cells are there? 7. So we are going to write 7 equations of this kind, right? I have written U1, U2, U3, V1, V2, V3, V4, V5. So first equation starts from this cell. This cell means U1, V2. So U1 plus V2 equal to what? 1. The next one is U1 plus V3 equal to 2. These values are Cij values. 4, 1, 2, 6, 9. The values given in the problem, no, those values are Cij values. So the first value equation what we are getting is U1 plus V2 equal to 1. This is U1 plus V3 equal to 2. And here U2 plus V1. U2 plus V1 equal to 6. And here U2 plus V3 equal to 3. And here U2 plus V5 equal to 7. And here U3 plus V1 equal to 5. And finally what we have is U3 plus V4 equal to 4. These are the equations, 7 equations. Using the 7 equations, we are going to find the independent values for U1, U2, U3, V1, V2, V3, V4, V5. How to start with? Let me take the first U1 value as 0. This is our assumption. We are starting with 0. So we have to substitute here. When U1 is 0, V2 equal to 1. V2 equal to 1. When U1 is 0, V3 equal to 2. So using these two, this U1 is 0. So V2 1 and V3 is 2. We got these two. After getting these two, try to substitute the value these two in somewhere, right? So check whether these two are there. Yes, here V3 is there, no? So V3 value we got as 2. So u2 is equal to 3 minus v3. v3 is 2. So it is 1. u2 is equal to 1. What is u2? u2 is equal to 1. After getting that, I can substitute u2 here. So this is 1. v1 is equal to 6 minus 1, which is equal to 5. So u1 is 5. After getting v1 is 5. After getting v1, I can substitute here. u3 is equal to 5 minus v1 is 5, which is 0. So u3 equal to 0. u3, after getting u3, I can substitute here. u3 0 means v4 equal to 4. After getting that, v5, come to v5, u2 is 1, v5 is equal to 7 minus 1. So v5 is equal to 7 minus 1, which is 6. After getting these equations, try to check whether the values what you got are correct. How to check that? Substitute that in this equation and check whether you got the correct answers. u1, v2. u1 0, v2 is 1. 0 plus 1, 1. u1, v3. So 0 plus 2, 2. Then u2, v1. 1 plus 5, 6. Then u2, v3. u2, v3, that is 3. And u2, v5. 7. Then u3, v1, 5. And u3, v4, 4. So we got the correct answers. I'm going to fill those values in the table. So u1 is 0, u2 is 1, and this is 0, and this is 5, and this is 1, this is 2, this is 4, this is 6. Am I right? Now come to the table. After getting ui and vj values, we are going to find a dij equation where dij equal to cij minus of ui plus vj for all unoccupied cells. These cells. The allotment is not there, those cells we are going to find. Actually, this procedure, why we are applying, we are going to check whether the answer what we got, the allegations what we got is a better solution or not. If all dij values are positive, we can conclude whatever we got using initial basic feasible solution, that is the final answer. If at least one dij is equal to 0 means the answer what we got is optimal, but there is one more alternative solution. We are not going to find the alternative solution, but there is a possibility of getting an alternative solution. Anyhow, we are going to write this as the solution. But if one dij, at least one dij is less than 0 means the answer what we got, that is not the optimal solution. We are moving into the next step. Okay, so let me check whether all dij's are positive or not. For that, first I have to calculate dij values for all unoccupied cell. For example, for this cell, first cell, how to find dij? Cij, that is 4 minus of 0 plus 5. 0 plus 5. 4 minus of 0 plus 5 is minus 1. So we are getting from the first cell itself, we are getting negative values. So write dij values at the right side topmost corner within brackets. So first value we got as positive. Come to the second value, 6 minus of 0 plus 4. 0 plus 4, which is equal to 6 minus 4, 2. And this is 9 minus of 0 plus 6, which is equal to 3. So this value we got as 2. This value we got as 3. Come to the next value. 4 minus of 1, 1. 1 plus 1, which is 4 minus 2. It is 2. Right in the right side corner. So we got all the values. I have filled all the dij values. This is the first value, second value, third value, fourth. And here 1, 4, 2. Okay, writing dij values, I will write the dij values at the right side corner within brackets, and the allegations I will write in the left side. Okay, in some books they will follow differently, but the formula is same, but writing the values may vary. Okay, I am following in this side. Okay, we have to check all dij or greater than 0. Is it greater than 0? No. We have one value which is lesser than 0. Which value? This value. So here we are going to start with the loop. What is a loop? Why we are drawing a loop? Why we are drawing means the answers what we got, no, the allegations. We have a feeling that those values are not optimal since one Dij value is not is negative, no, so the answers what we got is not optimal. We are going to try for a better solution. For that we are going to draw a loop. Where to start the loop? We have to start the loop from the Dij value which is negative. Okay, so here only we are going to start the loop. And if the case, suppose we have more Dij values negative, for example Dij values, two values I have, -1, -2. Where to start the loop? We have to select the most negative. In the negative value we have to select the least. Most negative means least negative. This is the least negative. I have to start with there. For example, if I have more than 2, -1, -5 and -7, we have to go with the most negative. In negative, this is the most negative, that is the least negative. So from there only we have to start the loop. Is it clear? Okay, since here we have only one negative value, we are going to start the loop from this cell. When we start, no, actually the procedure what we are doing is, this is an unallotted cell. Okay, in the next step we are going to make this as an allotted cell. Allotted cell means totally we have m plus n minus 1 allegations. No, extra if you add one thing means from that actually 7 are there. 7, if you make this cell as an allotted, newly if you are taking this as an allotted cell means we have to remove 1 from here because 7 already have, plus 1 means 8. 8 is not the case, 7 only we can take. So 8 minus 1. So somewhere in the allotted cells we are going to remove one cell. That is the procedure. So we are going to start the loop from here. After this cell we have to connect the cells those who are having allegations. The starting point is an unallotted cell and the other things we are going to connect, no, those values are unallotted, the starting point is an unallotted cell and we have to connect the allotted cells, and every row and every column we can connect only 2 cells. I repeat, we have to start the loop from an unallotted cell, then we have to connect all the allotted cells. In every row and every column we have to connect only 2 cells. Okay, so from here if I move row wise, either I can go to this cell or this cell. If I go to this cell and this cell got connected row wise, so 2 cells only I can connect, so I have to move column wise. Column wise no further allegations we have, so I am not able to connect this cell. So moving to this cell, in this row I have connected these 2 cells. Okay, so column wise, because row wise 2 allegations are made, so come down column wise only 1 allegations I have, so I can connect this cell. Next row wise I can move to this cell. Finally where I started, no, I have to end with that. This is the way how we can draw a loop. I repeat, the starting of a loop is an unallotted cell. Then I can move to allotted cells. In every row and column 2 cells has to be connected. So from here, either here or here I can move. If I go here, no further allocations can be made in this column, so I am going to this cell. Then I have come down, either in this row, then I can move this side or this side. If I go to this side, no further allocations can be made in this column, so I'm not taking this one, I'm moving this one. In the loop finally we have to end where we started, so I'm ending here. So okay, so now what we have to do is, the where we started, no, there we are going to allot a new quantity. Okay, so already it is an unallotted cell. Now I am going to take a new allotment. Let it be an unknown value theta. Theta is not known. Okay, Actually, we have 100 units. 50 plus 50, 100. 50 plus 50, 100. Now we have added theta. So 100 plus theta. That is not the case. Only 100 we can take. So when I take minus theta, theta and theta will get cancelled. Finally, I'll get 100. Is it clear? That is the procedure. If you start with theta, the next value we have to take minus theta. Now you see the row total 50. Then 50 minus theta, 50 minus theta, and this is plus theta. Minus theta plus theta will get cancelled. When we add these two, it is 100. So the procedure is where we are starting, we have to take plus theta. The next cell what is connected, that is minus theta. The next cell what is connected is plus theta. The next cell what is connected, it is minus theta. The next one is plus theta. Already we have plus theta minus theta. Alternatively we have to take. So if it is plus theta means here minus theta, 50 minus theta. Then minus theta means plus theta, 20 plus theta. Then plus theta means minus theta, 10 minus theta. Minus theta means already we have plus theta. Is it clear? Now we are going to find what is our theta. Theta is nothing but minimum of wherever we have minus theta. No, you have to see the allegations over there. I'm sorry, not this cell, this 10. Okay, so 50, 10. Out of these two, we have to take the minimum of it. So minimum of 50 and 10. What is the minimum value? 10. Therefore, theta is equal to 10. So we got the theta value as 10. Now we have to make new allegations. So we got theta as 10. Now again we have to do the calculation again. That is, here we have to take 10. This, there is no change because it is not there in the loop. This is 50 minus 10. 50 minus 10 is 40. Then 10 minus 10, 0. 0 means here only the allegations, we have removed the allegation. So newly we are introducing one allegation. Here we are removing the allegation. Now the total number of allegations will remain the same. M plus n minus 1. That is 7. Okay. Here 20 plus 10, 30, and here 90, no change, 30, no change, and this is 90, no change. So these are the new allegations what we got. After getting theta, I have substituted. Again, we have to find ui plus ui vj values, then dij values. We have to check whether all dij is greater than 0. If not, we have to repeat the same procedure, loop procedure. Until we get dij value greater than or equal to 0, we have to repeat the procedure. These are the new equations what we are getting for the allotments. U1 V14, U1 V21, U1 V32, then U2 V33, U3 V4, 7, then U2 V3, U2 V5, then U3 V35, U3 V4, 4. So how to find the values for ui and vj? We have to take u1 as 0. From that successively we have to get the values. So taking u1 as 0, I got all the independent values for ui and vj. u1 0, u2 1, u3 1. Similarly, I got the vja values. What next? We have to find the dij values for all unoccupied cells. So unoccupied cells means 1, 2, 3, 4, 5, 6, 7. These cells we have to find the dij values, and we have to make sure all the values are positive. For example, if I take this one, cast minus of these two, addition of these two. So 6 minus of 0 plus 6 minus of 0 plus 3. It is 3 greater than 0. For this 9 minus of 0 plus 6, it is 3 greater than 0. This is 6 minus of 1 plus 4, 5. 6 minus of 1 plus 4 means 6 minus 5, it is also greater than 0. And for this 4, you have to write in detail, okay, which I explained in the previous step. No, like that you have to write everything. For example, for this cell, we have to write 4 minus of 1 plus 1, 1 plus 1, which is 4 minus 2, which is 2 greater than 0. For this cell, 5 minus of 1 plus 3, 4 greater than 0 because it is 1. And for this cell, 2 minus of 1 plus 1, 2 which is equal to 0, and this cell is 6 minus of 1 plus 2, 3, so it is 3 greater than 0. For every cell you have to write in detail and you have to mention whether it is positive or not. Here all the values are positive, but we have a case of a 0 also. So we have all the Dij value. All the Dij values are positive and one Dij value 32. D32 is equal to 0. So we got all the values as positive and 0. No. So we are stopping the procedure here. Whatever allegations we made in the previous table, that is the final answer. So these are the allocations we have in this table. No. So that is the answer. We have to write it. So optimal solution is equal to 4 into 10 plus 1 into 50 plus 2 into 40 plus 3 into 30 plus 7 into 90 plus 5 into 30 plus 4 into 90. This is our optimal solution what we got. So I have written everything in the final answer. The optimum solution is equal to cast into the allotments what we made, 4 into 10, like that I have multiplied. And the final answer I am getting as the 1400. If everything is positive means this is the only solution. But one value we have 0, no. So we have to mention this statement too, that this is the final solution and it can have an alternative solution too. We are not going to find what is the alternative solution. It may have the other solution too. That statement we have to include. If everything is positive, this is the only solution, unique solution. If one value equal to 0 means it will have one more solution or more than one solution. It may have an alternative solution. Okay, so we started with TP and we used least asked method since it is asked in the problem. If it is not asked means we have to use VAM and we have to proceed optimal solution, that is Modi method. If all Dij values are greater than 0 means your work is very easy. From there itself you have to write the final answer. If suppose one Dij is negative means we have to proceed further. Loop we have to draw and we have to go for the better optimal solution. Is it clear? Thank you.